Hello students, in this video I will go through the derivation of the remainder and factor theorem. Alright, so in the past couple of videos we've gone through exercises on dividing polynomials, and we've gone through using the technique of long division, and then we've gone through techniques of using synthetic division. So let's take a look at what kinds of generalizations, okay, that we can make in dividing polynomials, okay? So what I'm going to do is I'm going to speak in very, very general terms here. I'm going to say f of x here is some polynomial, and I'm dividing f of x by x minus a. And what will happen is, time and time and again, okay, f of x when divided by x minus a, or some polynomial divided by x minus a, I will end up with some polynomial. And this polynomial that I end up with will always be 1 degree less than f of x. So suppose f of x was like a 4th degree polynomial and I'm dividing it by x minus a, I will end up with a 3rd degree polynomial. If f of x was a 7th degree polynomial and I'm dividing it by x minus a, I will end up with a 6th degree polynomial. And depending upon how f of x is related with x minus a, I will either have a remainder or I won't. If x minus a happens to be a factor of f of x, then my remainder will be 0. If x minus a is not a factor of f of x, then I will have a remainder. And if I do have a remainder, I will end up with a fraction like this, where p of x plus that fraction will equal to the original fraction, right? This is no surprise. You've done this a million times already. What I want to point out to you, okay, there are some generalizations or some patterns, okay, that we can extract from this. So suppose I take my p of x, which is, what we ended up after having gone through the division, and I wanted to add p of x with the fraction of r over x minus a. What I would do then is I would take p of x and multiply that by x minus a over x minus a plus r over x minus a. And in return, okay, what I will end up with is f of x over x minus a is equal to p of x times x minus a plus r, plus r over x minus a. Or, quite simply, f of x is equal to p of x times x minus a plus r. And again, if what I'm writing here, p of x is equal to, what I'm writing, f of x is equal to p of x times x minus a plus r is confusing to you, trust me, this is really no different from me doing this. 31 divided by 4, right? 4 goes inside of 31 7 times, right? 7 times 4 is 28, with how much left over? 3 left over. So what I'm saying is 31 is equal to 7 times 4 plus 3. That's all I'm doing. All right, so suppose now, right, what I want to do with this, suppose what I wanted to do is I wanted to evaluate, okay, I wanted to evaluate the function at a. What will happen then? Well, if I take a, right, and I don't substitute it, well, I don't know what f of x is. F of x is a polynomial, right? So suppose that I did substitute in some value into a polynomial, right? And what will end up happening is, on the right-hand side of this equation, I'll end up with p of a times a minus a plus r. If you look at this right now, p of a times a minus a, I don't know what p of a is, but a minus a, that goes to 0, right? So that means this whole thing, what will happen to this? This whole thing will become 0. So in other words, f of a will equal to r. So this f of a is equal to r. This will give me my remainder. This right here is the remainder theorem. So let's try to recap this, okay? So what exactly is a remainder theorem? So a remainder theorem says, right, if I wanted to divide f of x by x minus a, and I wanted to figure out what the to find the remainder, all I have to do is take f of x and evaluate it at a. That's all it is. F of a will equal to the remainder. Let's say if I wanted to take my function now and I wanted to divide it by x plus a, then the remainder will equal to f of negative a. So, wait a minute. If f of a will equal to 0, right? If f of a equal to 0, what does that imply? Then what that implies is then x minus a is a factor of f of x. This second part that I wrote here, the second statement here, this is the factor theorem. Here's everything in its entirety again. So really important, right, is that, here, I'm just going to move this because we're going to do that in the next video. What's really important to understand, the main takeaway one more time, is that when we're evaluating, when we're dividing two polynomials together, okay, if the divisor happens to be a binomial, all we got to do is just make that substitution and we can find out what the remainder is. If I know f of a happens to be a root, right, because that's what this is saying here, if f of a happens to be a root, right, then I know x minus a therefore must be a factor. Let's take a look at some examples, okay, where we can apply this so that it will make more sense.